So this is session 1, which is open source software and geospatial information. We're going to have the participation of 2 speakers. The first is Cristofer Maruc Muñoz Aguilar, who studied computer engineering and electrical engineering at 2 universities in El Salvador. And in his work experience, he's held different posts since 1993 at the General Directorate for Statistics and Censuses in El Salvador. And right now, he is the head of the Spatial Data Department. And from 2003 to 2012, he developed, or he was a consultant, professional consultant. He has helped create databases and analyze the viability of projects. He has generated quality programs for data and other positions. The experience that he's going to be talking about obviously has to do with the trends, software, free software, or open source software for the production of geospatial information. And these are the things that he has developed during his career in El Salvador and also as a consultant. Then afterwards, we will have the presentation by Carlos Fernando Ruiz Chávez. He is from Guadalajara, Jalisco. And in 2004, he graduated in computer engineering and he also has a master's in information from the university in the state of Jalisco. In 2004, he worked at the Institute of Information of the state of Jalisco as an independent or freelance professional, and he produced the Municipal Geographic Information System, which is a tool, a management tool in the state of Jalisco for various organizations or agencies. Then in 2006, he began working for the Territorial Information Institute, and today he develops programs for there that apply geospatial information for the processing, analysis, publication, and distribution of geospatial information. During his career, Carlos will also be talking about trends focused also or complementing what Cristofer Maruc will be talking about. And so he will be talking about his experience in his different positions and the different programs that he has developed for the state of Jalisco. So we will begin with Cristofer Maruc's presentation. Good morning. I hope you're enjoying these 3 days of events. I hope that by the end of this conference, all of us will have acquired new knowledge and that we will be able to make good decisions because our environment definitely needs it. Let me introduce myself. My name is Cristofer Maruc Muñoz. I work for the General Director for Statistics and Censuses of El Salvador. I am right now the head of Spatial Data Department. And to begin to talk about the next slide, please. The next slide, please. We're going to stress a little bit from where we're coming from in terms of geography and geographic information systems. Well, at first we were working with slides, and at the beginning we used to do analyses with slides, and each slide represented a layer of geographic information, but that was a long time ago. Then we had digitalization, and there were digitalization tables, and we had to have a mass. And even in my country, we worked with the transparencies, and then we would paste those on the screen. Well, today it's completely different. definitely we need to have information technology, computers, and cell phones, and smartphones, and everything that is revolutionizing information technology in geographic aspects. The next slide, please. Okay, so using open source software right now at this, where we have budget reductions and financial crises, and as we saw during the welcome at the General Forum, we're seeing that these mean significant investments. If you want to establish a geographic information project, it's very expensive in reality. But we also have the alternative of using open source software, which in reality means open source. He just said it in Spanish. And that's really more of a concept for developers, but you can use, ultimately, we can use the software that's free and that's useful to us. Now, who creates this software? Where does it come from? Well, there are communities of developers who are in charge of creating this software, of updating them, modifying them. This sort of software, well, all softwares, most of them, I mean, we acquire a contract, and sometimes you don't have a contract, and you just download them from the internet. But you have to be aware that software that you download from the internet and that is not backed up by any company, well, they can either fix our life or they can ruin it. So we have to be very careful with those sorts of software, that sort of software. Next slide, please. So, what do we need to get a geographic information system going? Well, we need computer equipment, either servers or stations that connect to these servers. You need GPS, smartphones, tablets, things that you can use in the field. And at some point, basically, maybe you can say that they're not necessary, but for a robust system, we do need them. We also need software, which in this case we're talking about free software, open source software, and it is possible to do an entire project with free software. But you have to be careful, because all of this hardware and software has to work together. So the versions, it's important that you have to take into account the versions that are compatible one with the other and that the software can interact. Now, where can we start researching all of this? Well, you can research it on the following web pages. This page is very important. It's called Open Source GEO, which means Open Source Geospatial. It's from the foundation. And here, this is very important because we can find links to be able to download the open source software in a geographic environment. Here there are forums, communities that can guide us to establish a sort of first step so that we can begin or start up our systems. Next slide, please. Now, what are the sources for spatial data? For us to be able to work the geographic information systems, we're going to need data, geographic data and geospatial data. In this case, a long time ago, companies had to pay quite a lot of money to get digitalized geographic information for photographs, satellite imaging, etc. But now, today, there are several ways of getting geospatial data online. Now, where? Well, first there was Google Earth. That was one of the first. It was one of the first applications which started digitalizing information. Of course, Google Earth has a license, it has a free license and one that you have to pay for. But if we're thinking of free licenses, we're talking about that we need to digitalize all of that information that Google Earth can present as an image, just like there are other sites like Bing and OpenStreetMap, which is a pretty good website. Next slide. This is servers and workstations. Now, what features do the servers and workstations need to have? Well, the most important thing is that they have to be able to handle large volumes of geospatial information. As we all know, these volumes of information are very heavy. And it would be useless to have workstations that are fast or fast servers if they don't really satisfy the needs one of the other. As I said at the beginning, they have to work together. Next slide, please. So this is hardware and just like the hardware and communications equipment, it also has to be able to handle those large volumes of information. Next slide, please. Now, what is the software that is used for GIS systems? If we were to separate the software depending on how it's used, we need operating systems, a database manager, spatial software for working with geospatial data or that connect to geospatial databases, and some other different types of software that indirectly participate and help us in other ways so that our information, so that our GIS systems can work. Next slide. Now, what about the licenses? If we were to divide this by license, the software, we can talk about three main types. There are several types or various types of licenses, but the main ones we could say are these three. One, they are private or proprietary, where you do have to spend a certain amount of money to use the software. This sort of license, it's a legal contract, and it tells you how many copies you can have of the software. It tells you if you can transfer the software to another computer or another machine. It's all set down. And the next type of license is the open source or public licenses, where we don't have to pay for this license, but also these licenses have certain types of restrictions as far as their use is concerned. In some cases, the user is told that if at some time he modifies the code, because it's open source, if there's a developer who changes or modifies the code, he has to give this modification to the company where he obtained the code. But this is just one type. It doesn't necessarily that all open source software works this way. And then there's another type where we can get information that was obtained via a software that was acquired as an open source. And then the last one, it says software without license, which are the ones that you download from the internet, and it's the ones we have to be the most careful about. Now, there are different types of software depending on how you use it. So necessarily in this case, if we're talking about free software, then we have to talk about Linux and its different versions, both for servers and workstations. Debian is a very good Linux version, which is very stable. We also have Ubuntu, which is generally used locally or at home. It's really for home use. But there's something that should be clarified regarding this type of software. Not all developers are prepared to handle or manage them. In other words, the developer, the administrator has to have the necessary knowledge to be able to work with them. And Otherwise, then they really need to get the training. So there are two other software which are pay, for instance, Windows and Mac OS from Apple. Okay, Windows, I don't know if you realize it, that sometimes we buy a computer and it says that Windows is already pre-installed. And those are the sorts of alliances that companies do, and theoretically they are free, just like when we have a phone and the phone already has an operating system. The next slide, please. Next slide. Now, no, let's go on to the next slide because I already talked about Ubuntu and Debian. And Ubuntu is made really for the public. It's geared more towards the home user. Now, these are operating systems for mobile phones. Among those that are free, Symbian, well, I think Symbian doesn't exist anymore on the market. But we have Android, which definitely both use as Linux as a base. That's why they continue to be free, and I hope that they can always continue to be free. Among those that you have to pay for, we have iOS, Apple, BlackBerry operating system, and Windows Phone. Why do we need to know all this? Well, because at some future point, and even now, you should know that your developers, they have to develop apps and application for these sorts of operating systems. Even though they're pay or free, definitely the developer has to be trained so that he can work with these systems. I mean, we're not going to just stay with the workstations and the computer when the smartphone and the tablet market is increasing exponentially compared to computers or desktops and laptops. Next slide, please. Now, we continue talking about software depending on its use or how it's used. So let's talk about database storage. Not all of them are able to manage geospatial information, both proprietary and free software. When we talk about not all of them can handle geospatial information. If the software doesn't allow it, there are of the free ones we're going to talk about two specifically. We're going to talk MySQL, but the problem with MySQL, what we can say is that it manages very small amounts of information based, I don't know if it's 10 gigas, where we can't handle information. If we want more, if we're going to have more than 10 gigas, then we have to pay for a license. But we do have something that we have, there are other, the post-GIS, we need to install that as an addition, and it's an excellent database storage application. And generally, we're talking about a manager or an administrator that can manage the same as Oracle. And then for software geared, oriented to GIS, the most famous are Quantum C and GIS. And it depends on the user's need, because it's pretty variable. People have different opinions regarding each one's capacity. These are the ones that indirectly help us to keep our geographic information systems online, to be able to offer information. Apache Tomcat, which is, there's another map server that's called GeoServer. There's also map servers. And we also have open layers, which are a type of pages that we can modify with JavaScript and then customize them to what we need. We also have Eclipse, and Java, and this is Eclipse is definitely for developers, for that they can develop their geographic information systems. This would be like a graph or a chart of a basic server on the left and a local user on the right. And these are using open source. Next slide, please. Well, that's it. Thank you very much. Okay, so thank you to Cristofer, Maruc, Muñoz, Aguilar. Perhaps I made him go too fast when I warned him that he only had 5 minutes. But he's here to answer if you have any questions, or later on when we finish. And now we'll give the floor to Carlos Fernando Ruiz Chávez. Good morning to everyone. Before I begin with my presentation, I'd like to thank the UN and the National Geography and Statistics Institute for the invitation. It was very agreeable for me to get an invitation for this event, especially for this particular, on this particular topic, which is my forte, which is geospatial information technologies. And we're going to see what are the current trends. And we're also going to be talking about the experiences of what we're doing, or what we've been doing for many years in Jalisco, having to do with geospatial and using software. Next slide, please. What is open source software? Open source software is not just applications and softwares that are cost-free in terms of licenses, but there are 4 degrees of freedom that we don't take advantage of. One is use. The other is to know how the software is created. We can modify it because we know how it works, and we can customize it, and we can distribute it freely to other users. Next slide. Well, based on this, it's important to say that the fact that it's free, it doesn't mean that it's, a cheap and bad product. It follows certain methodologies so that the quality of the products are assured. And behind a good software product, because there's also a myth that open source software doesn't have documentation, etc. But I'll tell you, always behind one of these this open source software, there is an enormous community that's behind it. So the first trend, which are spatial databases. And so we're talking about working with spatial databases that enables us to simultaneously access different data, and we can also store it. And I can also create very complex queries with these sorts of tools. This is an analysis that we did regarding noise in the city of Guadalajara and Jalisco, and we put this into Google Maps. And the entire analysis doesn't come from a GIS. We used a lot of the information of the INEGI, and then we started analyzing the databases. I started generating the information via geoprocessing and spatial predicates. Another one was to detect forest fires. We worked with some of the satellites from NASA, where we identified points where there were anomalies for the sensors, and we mapped influence areas, and then we identified the polygons where, in terms of time and proximity, we were able to detect forest fires. All of this is done without human intervention thanks to the databases. Something that's interesting is the publication and distribution of information. I work for the government, and it's important to understand that information is an asset. Information it's not in a hard disk in a drawer somewhere. It generates value, and it has to be available through the internet. And this really takes us to cutting down the doubling, or let's say that a ministry spends $1 million pesos on information, and then it doesn't publish it, and then it's okay, I lost the sound. Okay. And then it doesn't publish it, so someone else does the same work, and so you're doubling up on the work, and another ministry may spend the same amount of money. So one really has to think about publishing the information, making it available. The next slide, please. Next slide, please. So these are OGC web services. What we're seeing here is a photo of the metropolitan area of Guadalajara. This cost 14 million pesos and is 33 gigabytes, and you can download it in 2 seconds from a GIS. Next slide. We also have satellite images, Landsat 5 and Landsat 7. This is vectorial mapping, and we're seeing the drainage of the city. We worked with the municipalities in Guadalajara, and it's for urban infrastructure, and this information is available, and we've published more than 70 web services from OGC, and we have an average of 6,900 queries or hits a month, which is pretty high. And these products that are free respond pretty well to the demand. Now, this is GIS on mobile devices. This is important because it's a very trend, how we're working with information from mobile devices. And we have to leverage Cofetel in Mexico. They said at the end, in December 2012, that there was over 100 million telephone lines that had mobile devices. If we add tablets, then there's a huge amount of devices that we need to take advantage, and we should take advantage of, that are on the street to be able to update and integrate geospatial data. Here we're seeing online digitalization. This is a roundabout in the city of Guadalajara, and how we're doing accessing it through tablets and via Android, and we're digitalizing. These are roads, and this is a project that we're working with the traffic ministry in Jalisco, so that the traffic agents who are always moving around, they can update the infrastructure and the signaling. And in terms of the back end, there's a transactional service. In other words, the service isn't just a receiving information, but they can go back and forth to update the information, and then we store it, and it's reflected in real time what we're working on. The next slide. Now, this is business intelligence, which is a concept that has a lot to do with the commercial area to offer information to support decision-making for managers and CEOs and so on. If we apply it in the government, we can see that this sort of technology can be applied to geospatial information, and we can support the decision-making by municipal authorities, state authorities, the government, the President of the Republic, the minister, etc. Whoever can make decisions that he or she should use this to analyze information dynamically and to detect trends and relationships, and this can also be in real time, so that we can handle or address phenomena in a timely manner. This is a map of Jalisco with the roads. This was created in GPS by going through the entire network of roads, and it's mapped or drawn, and it classifies each municipality according to its degree of marginalization. The red is the most marginalization, which is where most indigenous communities live in Jalisco, and then we have the southeastern and southern coast of the city. But if we analyze if there's a relationship between land connectivity and marginalization, urban marginalization, we can see the first thing that we can see, and this is just an explanatory exercise, is that where there is very high marginalization, there are very few land connections. And if we play with this, we can see another pattern. We do not have roads that are federally managed in places where there is very high marginalization. Next slide, please. Finally, to tell you that in the territorial information system, we work with a whole system of open source stuff. There isn't one product that can solve everything. It's really, if you want to build a house with a screwdriver and you say that with a screwdriver we're going to use it as a hammer and as this and that, this, that, or the other. No, each tool has a specific task that it has to implement or use. Map server, I'm going to talk a little bit about this. Map server is a map server, as it says. It isn't that somebody is in a corner somewhere and just created this product and launched it onto the internet. No, map server, this is the federal government, state government, and academics to generate this product. We're talking about NASA, the Minnesota Department of Natural Resources, and the University of Minnesota, who came together and they created this product in the mid-90s, and it has continued to evolve. In the case of post-GIS, it comes from a product that's financed from the Defense Ministry Department in the U.S. with the Berkeley University. And that's how it began. And POS GIS was developed by a Canadian company in British Columbia, and it's what enables, as Cristofer was saying, so post-GRE works with post-GIS. Geomondrian is what we're doing with the hypercubes. It comes from the university in Quebec, and it's open source. And as you can see, academics and the government are very involved in these sorts of products. It doesn't happen in a vacuum by two or three guys who sort of did it like Facebook. No, it's something that is really very, very serious. So my conclusions, before they put out the red card and tell me I only have 3 minutes left. So free software represents a true or real alternative. It gives us a new model. It presents a new model. Many people ask, where's the trick? Where's the catch? Why? It's free, so where's the catch? But no, it breaks with what we're used to, that we pay for software and it says only one user can use it, and if you share it, then they're going to cut your hands off. No, it doesn't. This is a new model, a new software model where knowledge is generated. And also, as I was saying, it includes very high-quality products that are reliable and robust. We've been using them for many years, and so we've grown with them. We've been part of them. I belong to two open-source communities where I answer questions from people in India, from Italy. I worked with a Frenchman on a small project that I didn't mention. It's a service that enables that what is being done locally on a desk or on a mobile application is stored on the server. And it's like a joke, we were a Finn, a Frenchman, and a Mexican working together. And it turns out that this project was absorbed by Map Server. And it's already part of Map Server. Next slide, please. So the conclusion is they're really geared a little bit to governments. The zero cost for licensing enables us to spend that money, or rather invest it in that we can gear it, for instance, to social programs and other things. Spend that money on other things that are more profitable or that are more cost-effective. The government maybe doesn't generate money, but it does generate social value, and so we need to optimize the resources. And it also helps to fulfill the austerity policies and guidelines. It's a good option. The next slide, please. And then in closing, when you know how the software, we talked about that we're part of the information society. And now we're in the knowledge society. And there are economies that are based on that. If we have the freedom that open source software gives us, then we generate knowledge. It's not a question of being super users of a software. I know that there is a commercial brand that many people, because of their professional education, they're taught to use that software, and then when they go out into the workplace, they look for that software. Because really education, that's where they geared them. And they're geared to learning how to use that software instead of how the process works. But a free software can do exactly the same thing as a proprietary software. The exact same thing. What's important is how you're going to use it, not so much the software per se. In our needs and what we've used it for, we don't see a big difference between open source software and proprietary software. And to generate knowledge, because when people come up against these sorts of software, they don't just learn to click to do something, but they understand how the process works, and the model itself invites you to get to know how it works. So it generates knowledge, and the question and the challenge is, why do governments and the private sector and the academics, why don't they get together? Why don't they leverage this freedom to create products and services that can be customized to the needs of a market segment or a social need? So I leave that question on the table. Next slide. So thank you very much. I hope you enjoyed these 20 minutes that we have as much as I enjoyed talk to you very briefly about what we're doing in Jalisco and my experiences. Thank you very much.
We already have 2 questions that they have submitted to us. I don't know if there are any others on the room. We will be starting with the first that was made by Felipe de Jesus Castro from Autonomous University of the State of Mexico. I have managed MapInfo for many years. I wanted to migrate to open code. I started operating with GeoBasic, and due to the amount of failures and lack of productivity, I came back to a license product. How does open code affect productivity? Which open source Gs do you advise me to use? When Cristofer, yes. As it applies for both, I would like to ask both of our speakers if you can give an answer to this question. And the other one is Formula 2, that is Felipe, and he's saying, what OpenGIS do you advise me to use? Well, definitely there is no, as my colleague had said, there is no one magic formula that will apply to your case in 100%, and that will be solving all your problems at a functional level. So if that GIS did not work, you can use Act2Me, so you can try another software that is good as well. And this question is very important. When you use it, what version of the product you use? Because remember that products evolve within time. Maybe it was a very new product, but we work with Cosmo, which is a Spanish version. But regarding on GIS, we know it's very strong, it's very good if you have to manage things such as ArcGIS and ArcGIS. Next question was made by Rodrigo Jimenez, who comes from the UNAM. What are the advantages of priority software versus the one that's not? Proprietary. Proprietary versus non-proprietary. Well, talking about Oracle, talking about Postgres, I would say the advantage of Postgres versus Oracle, I would say good amounts of money that you have to pay Postgres, it's not. So up to the very little experience that I have, and I have the opinion of a person that has a lot of experience with these kinds of softwares, I would say that there's not a huge difference between them. Sorry. It's kind of uncomfortable here. Well, in my case, I would like to say that obviously what Cristofer is saying is true. The difference is I know very little about Oracle, but Oracle has a higher cost. But the advantage that I see in Postgres is because of its design. It has no limitations regarding storage. So I don't know if Oracle can say the same. I don't know. In Microsoft School Server, it's saying that up to some versions, you get 4 gigabytes or so. So the other one is, well, you have unlimited storage capacity. It's going to be Silvia Gonzalez, well, from the Secretariat of the Environment for the State of Coahuila. We're developing an military information program on the state, and we had a transfer of technology from software built from SQL, Jumbala. Jumbala? Joomla. And PHP. That is a free software. What kind of free software do you advise us to use for spatial purposes, and try to link it to the platform that we have mentioned? Well, Joomla is a content manager. It's also free. When you're talking about publishing information, I think that you are talking about Dynamics. HP, well, we made a viewer for information viewers similar to Google Maps. We started out in 2007, and we use MapScript that comes with Map Server and that allows you to make dynamic applications. And it's working with Python, HP, and other. So you can use MapScript on open layers, and it's already integrated with OpenServer for Map Server. From Climate Change and Environment Secretary, what is the great challenge of using free software in GIS application in the sector or in federal administration? And he is making some hypothesis from that question. What is the curve of learning in these tools and that standardization of data? among institutions, alliances with proprietary software? Jesus, I hope that I have made the question properly. I have raised that question properly for you. Oh, that's such a good question. I think that what you are saying, there's something that I did not mention about free software, which I normally do, but free software is the one that sticks more to the international standards, W3SO, GI, and GISO. And in a state that creates information and they linked it, what is important is that we should talk about interoperability of the information that has 4 levels that goes into the governance. It is not the topic for this panel, but learning curve is another factor that you are mentioning. It's not that different from this. But as I was saying, it's opening a door for something that the proprietary software does not allow you. But learning curve, I can say, is a little bit longer than what is a proprietary software learning curve. Definitely, with learning curve, you have to do research regarding softwares. And what happens is that we are used to work with proprietary, and we don't know a lot of deal about the other free source software. Senasa, with the employment of free softwares, can you have the new trends of GIIs on the cloud that's provided by proprietary software? Henry is selling this software to state-owned companies. How can an open source software respond to this? The only thing that I know about this is that you have an Apache Hadoop application, which is the one that is useful to organize this kind of information on the cloud. But up to date, there's nothing free. This question is interesting because I don't know something about free software that's working on the cloud. Normally, what we have been talking about are databases, relational databases, data structures that you go into the cloud and you have to talk about other products like Hadoop, Mongo, among others, and there should be some APIs that work with this kind of databases that we call big data, that's super columns, that is data that is highly structured. I don't know if there's a product on the cloud. I don't know if GIS has something of a server that you can publish information. I do not know about it, and I haven't worked with it either. Dicena Peralta from Meteorology Service, National Meteorology Servers, how to manage time in the use of free software and how to manage people that are used to work with proprietary softwares. Well, I believe that to that regard is more a matter of organization, is how to deal with people that are using the proprietary software. Yes, all changes are costly because all changes are difficult, but you have to make people aware about the benefits that the institution will obtain by using that free software instead of a proprietary software. The resistance to change is normal on human beings. Alike, if a proprietary software issues version 11 that's different, completely different from 10.1 that was the latest one, obviously there will be users that will be saying, well, leave me with the older version, I like it better, and they will be rejecting change. But sometimes you have to keep on moving and you cannot stagnate. So sooner or later, a change will have to be done. I thank you for your participation. I'm not for what Carlos said during his presentation. He could make further comments later on, but I want to share this question with you because it's very important to me. Eduardo Chávez in Science and Technology on Sea and Geographic Information, and he's saying we have been working SAGA-GIS for 4 years to have technicians on GIS. And I thank the participation of all of you because I think I went over time. Thank you so much.